It's minimum for cesium 2.14 electron volt, maximum for platinum with 5.65 electron volt. Next, the observation that we made was photoelectric effect is possible when the frequency is greater than a certain threshold frequency. So E should be greater than 5 naught, that gives H nu greater than 5 naught, that gives nu greater than 5 naught by H. So here nu naught is called the threshold frequency of that particular metal. One of another aspect here is that the threshold frequency, it depends on threshold energy or work function, obviously on the metal and nature of surface. So these are the theory parts for this particular topic. Then we have some graphical analysis of threshold frequency and the work function. Then we have the tan theta, which is equal to 1 by h, which is constant for all metals. Then another observation is that for photoelectric effect emission, wavelength has to be less than a particular wavelength, which we call as the threshold wavelength. So using the concept of work function, the concept of lambda naught can be derived over here. So here lambda should be less than or equal to lambda naught. Again, it depends on the work function, depends on the metal and nature of surfaces. Now there is another thing that lambda naught is proportional to 1 by 5 naught. This can be derived over here. So if we draw the graph is going to be a rectangular hyperbola. If we analyze the graph, we can say that if work function increases, threshold wavelength decreases, and if work function decreases, threshold wavelength increases. So these are the graphical variations of different parameters. Now there is the photoelectrons are emitted with a range of kinetic energy, which is obviously due to collision of the emitted electron with the crystal in the metal. So electrons are emitted with a spectrum of energy ranging from a minimum to the maximum value. Minimum value is 0 and maximum is Kmax. So here is the concept of Kmax, and Kmax is corresponds to that electron which does not involve any collision with the crystal, with the electrons present in the crystal. So Kmax can be calculated as half mv max square is equal to Kmax. From here we get expression for Vmax. If we draw the graph, this will be the graph between Vmax and Kmax. That will be parabolic graph. Now there is a question involved over here. So this is the question, and you can see the various parts of that. So in this way we can prepare optimally for the result. Thank you and have a nice day.